So in this lesson I'm going to be developing formulas for finding areas for parallelograms and actually for all triangles. In the last lesson we looked at finding areas for rectangles. We said that the area of a rectangle we said in the last class was equal to its base times its height, or its length by its width, however you want to think about that. And in order to develop a formula for a parallelogram, I'm going to link heavily in with this formula for rectangles, because every parallelogram can be cut in the following way. We can kind of cut vertically along a line here and remove that kind of little triangular piece at the edge. Remove that. Notice it's actually a right triangle. But if I take that piece and put it over here, you know, what we have is a rectangle. And when we're trying to find the area of the parallelogram, we're trying to find out how much two-dimensional space it covers. How much blue is on the screen here in this parallelogram. And you'll find that, well, the amount of blue that's on the screen, the amount of area it covers, is the same as this rectangle. So the area for finding the the formula for finding the area of a parallelogram is pretty much the same thing as the area of a rectangle, because every parallelogram can be turned into a rectangle. We take its base and we take its perpendicular height, and I suppose that's the key detail really, that we're talking about the perpendicular height of the parallelogram. Okay, we're not talking about what we call the slant height, which would be this distance along that slanted edge there. We're not talking about that. We're talking about the perpendicular height, how tall it is. So it's base times perpendicular height, and that's the key detail there, that you remember that height here is actually perpendicular height. So you'll often see it written as base multiplied by perpendicular height, like that. Okay? But if you understand, if you can visualize that every parallelogram can be cut and changed into a rectangle, this should make sense. So to find the area of this parallelogram, which has a perpendicular height of 8 units and a base of 10, well, all I need to be able to do is kind of cut off a piece and replace it, and I see I have a rectangle. And we've seen that the area of a rectangle is base times height. So the area of the parallelogram is equal to base times height. In this case, the base is 10, the height is 8, so that's equal to 80. And again, it'll be whatever the units are squared. That's how we find the area of a parallelogram. It's essentially the same formula. So the area of a parallelogram is the base times the height. I can cut every parallelogram. I don't need to go and do it. I just need to be able to visualize. I need to understand the formula, I suppose. I need to be able to visualize that every parallelogram can have a right triangle removed from its side and replaced so that it forms a rectangle of the same area. But the formula, if you just remember it, in fact it's in your formula and tables booklets, the area of a parallelogram is equal to base times height. It's pretty easy to remember. It is given to you in your formula and tables booklets. Okay, the area is 60. Find the measurements of parallelograms. We're trying to find the area, we're given the area here. We're trying to find the base. We're given the height. Okay, remember, area is equal to base times height. So we can write that in any of the following ways. Area equals base times height. Base equals the area divided by the height. The height equals the area divided by the base. We're trying to find the base here. Well, the base is going to be the area divided by the height. The area here is 60. The height here is 12. 60 divided by 12, that's 5. And whatever the units are. so the base is 5 units here. Obviously this is not a very well drawn parallelogram. If the height is 12 and the base is 5, it's not drawn to scale, but that's what the base is. Okay, so the area of a parallelogram formula, make sure you know it. Here I'm looking for the height, and again, area equals base times height. So the height is equal to the area divided by the base. We're given the area here is 35. We're given the base is 10. 35 divided by 10. That's 3.5. And the units, whatever the units are, they might be meters or centimeters, something like that. You have to include those. So the height here is 3.5. Notice it doesn't always work out to be an integer or whole number. Sometimes we get things that are not whole numbers. That's okay. Area, base times height. Okay, and we're going to start using this formula for the area of a parallelogram in order to generate the formula for areas of all triangles. So in order to generate the area of a rectangle, we needed to know what a unit square was, and then we were able to very easily establish the area of a rectangle. From the area of a rectangle formula, we derived the area of a parallelogram formula, and from the area of a parallelogram formula, we're going to derive the area of a triangle formula. So I want to find the area of this triangle. It's not a right triangle. I want to think a little bit about it. An important thing to note, or the key to really understanding the triangle area formula, is this: that every triangle can be copied and its image reversed, turned upside down, and stuck on to form a parallelogram. So every triangle is half of a parallelogram. So the area of a triangle is always going to be half of the area of its corresponding parallelogram. And we've already established that the area of a parallelogram is base times the height. So the area of a triangle is half the base times the height. So the area of this triangle will be half the base, which is 5, by the height, which is 8. If I was doing this in my head, I'd say half times 8 first. It's easier than finding half by 5. Half of 8 is 4. 4 5s are 20. That's probably an easier multiplication than half of 5. 2.5 times 8. But either is good. So the area here, it's area, so it's units squared. It's units squared. Key detail, of course, that we're talking about the perpendicular height, not the slant height here. The slant height is usually denoted with the letter L. So to find the area of a triangle, it's just half the base times the height. The area of a triangle, half the base times the height. So you have to remember that formula. It's half the base times the height. The key detail is to remember that when we're talking about the height, we're talking about the perpendicular height, or the altitude of the triangle. That's also often called the altitude of the triangle, the perpendicular height. And actually any side can be used as the base. You just have to measure the perpendicular height from that side. So half the base times the perpendicular height. Area of every triangle is just half of the area of its corresponding parallelogram. Another way to say that is, if I double the area of a triangle, I get the area of its corresponding parallelogram. Okay? Because every triangle, is half of a parallelogram. So getting used to these formulas is really important. Here's an example where I'm given the area of the triangle, I'm given the base, I'm trying to find the height. The area of a triangle we know is a half times the base times the height. Substituting in here 20 for area. 20 is equal to half times the base of 4 times the height h. So 20 is equal to 2h. Divide on both sides by 2. And that will cancel that 2 on the right. If both sides of an equation are divided by the same quantity, then the two sides remain equal. So we get 10 is equal to h. The height is equal to 10 units. Not units squared, it's just a measure of distance, not a measure of area. Formula for the area of a triangle is given in your formula and tables booklets. In our next class, we'll be looking for finding the area of a trapezium or a trapezoid, but for now, get used to finding the areas of triangles, of parallelograms, of rectangles, of right triangles. Practice loads of these exercises, get used to the formulas. Okay? Practice, practice, practice.